First, number 16. Can you tell that it has 3 pieces? 1, 2, 3. Okay, so I drew 3 tables, which for some reason always remind me of those signs that you put in front of your house when you're selling your house. They look like realtor signs to me. I don't know why, but so I made 3 realtor signs. And this one is going to be x negative 3 to the x. This one's going to be x and 4. And this one is going to be x and x minus 4 squared. Okay, now you have your table set up, I hope. We need to figure out what the x's are in the tables, and this is the hardest part about the piecewise, in my opinion. So the first piece, it says x is less than negative 2, but still start your table at negative 2. So negative 2, then go less than. I don't even think we're going to do negative 5, to be honest. So we're just going to do negative 2, negative 3, negative 4. You'll see why. Okay, now in this piece, it tells you to go from negative 2 to 3 and your x's. And in this piece, it says x is greater than 3. So start at 3 still. That's a different thing. That's when you're finding the exponential equation with the b's, like counting the b's. Okay. Now we're going to do mental math. So negative 3 to the negative 2 is negative 1/9. Okay, just think about that. So the negative makes it negative, and then that goes to the bottom. See what I mean? Here, let me do it up here. Like this. Okay, so I took 3 to the negative 2 and I circled it, and I brought that to the bottom. You see what I did? And the negative stays there separately. That's why it's negative 1/9. Of course. Okay, so this one will be negative 3 to the negative 3, which is negative 1/27. And this is negative 3 to the negative 4, which is negative 1/81. And you guys can see why I didn't want to go any further than that, because these are almost impossible to graph as they are. Okay, however, table 2 is my favorite. It says that it's 4. It's amazing. Yeah, me too. Okay, so 3 minus 4 squared. So 3 minus 4 is negative 1 times itself is 1. Zero. 1. 4. Okay, now we're going to find our boundary points. The boundary points are where these things are. So this is telling me this first one is open at negative 2. So I'm going to put an open circle there. This is telling me it's closed at negative 2 and closed at 3. Closed. Closed. And this is telling me it's open at 3. I gotta make it more open for my failing eyesight. Okay. Yeah, one's open and one's closed, and that's what keeps it a function, by the way, because otherwise it would fail the vertical line test, if you think about it. Okay, anyway. All right, so we're gonna start here. -2, -1/9. Just really hard to grab, but just like right below the x-axis, make it obnoxiously open so that your teacher with the failing eyesight can. -1/27, -1/81. Just remember it's approaching the asymptote. Oh no, I touched the asymptote. Yeah, it's getting bigger technically, but closer to 0. I still touch the asymptote. Okay, -2, 4 is closed. -1, 4, 0, 4, 1, 4, 2, 4, 3, 4 is closed. Yeah, that's my favorite. Okay, and then 3, 1 is open. 4, 0, 5, 1, 6, 4. Okay, and then just to check, this looks like an exponential. This looks like a constant. This looks like a parabola. Okay. Check mark. It's good. I like it. It's not great. Okay, when you're done with that, scroll down for the 2 spicy special right triangles. These might be better. I don't know how you feel about them. Let's put the formulas on. So this is the x√3 side. This is the x side. And this is the 2x side. Okay, and then because the x√3 side lines up with the 2, I say x√3 equals 2. Divide by √3. You see where it's going? Okay. Can't leave a root in the bottom, so we rationalize, which means make it into a rational number. Okay, can you, in your mind, go √3 times √3 is √9, which is 3. Okay. If you want to write √9 and then write it again equals 3, that's fine. But yeah, you can think of it that way too, like it's times itself, so the squares and the square root cancels. Perfect. Okay, so this side is that because it's just plain x. Okay, now this side is 2x, and what you have to remember is you just multiply the top number in the front. So again, just multiply the top number in the front. So you have m equals 4√3/3, and n equals 2√3/3. You seem to like this better than piecewise. No? Okay, now let's write the formula on here. So this is x root 2 x root 2 equals 4. Divide. Get x by itself. Okay, what should I multiply by? Beautiful. That's good. Okay, so 2 root 2, 2 root 2. Okay, this is your friendly heads up that all of your warm-ups should be done now. So take a look through your warm-ups. If you're absent, those are on video, or you can get them from your group mates. I'm not going to stamp them this minute, but I will stamp them just so you know they should all be done. Okay. All right. Now we are moving on to completing the square. So what I need you to do is go back in your notebook to August 18th, where you have the notes for 1-29 to 1-30 notes quadratic equations. Yeah, if you can't find it, just start it on a new page. It's not a big deal. But this is what you're looking for. And in the notes for quadratic equations, we left some space for number 131. So it looks like solve by quadratic formula, and then we left space for completing the square. And again, if you can't find it, just put this at the top of your page. It's no big deal. Okay. So step one, most of your quadratics are going to be equal to 0. When you complete the square, you want to move the C term over. So this one's already set up for complete the square. The C term's already over there. So we don't need to do this step, but just saying, for step one, make sure your constant's on the other side. Our constant is on the other side. Step two is complete the square. Now I complete my square with a box. A lot of you guys have been taught tricks to use instead of the box. I'm going to use the box. It's up to you if you want to use what you previously learned, but I'm going to use a box because I like to use the actual square and complete it. So my motivation is I'm actually showing completing of a square, but then again, I also am going to use my box for the factoring piece. So what I'm going to do is take my x squared and put it in the first box. And then because it has to be a square, I break up my 6x tiles into 2 sets of 3x tiles. Does this make sense? So I put x squared in the first box, and then I take my 6x tiles and I split them into 2 equal piles of 3x tiles because it has to be equal length because it's actual square. Okay, then I find the outsides. And this is where you find the constant of 9. Then you add the constant to both sides. So plus 9, plus 9. And this side is x squared plus 6x plus 9 equals 25. Okay, step 4 is to factor. So you would have to diamond and box this, except for that we already did it. X squared plus 6x plus 9 is x plus 3 squared. Because we did the diamond and box already over here. Do you see that you can find this on the outsides of the box? And then the last step is to solve by square roots. So square root both sides. Don't forget your plus or minus. And hopefully that's the same answer we got in the other problems we did that were the same problem. Yeah. Okay, now find new spot in your notebook where you're going to put new stuff. Yes, okay, so guys, start with number 135. We're just gonna do A right now. The book, seems to assume that you remember how to do all three different types of completing the square, which you probably do not. We just did there's three kinds, yeah. So that was the first kind that we did, which is number 135A style, where you have just like a plain quadratic. So let's go through the steps that we just learned on number 131. This is different, so we're just gonna look at 135A right now. Okay, what was step one? Move the constant. Beautiful. Now make a box. And remember, this box actually has to be a square. So the two x terms have to be equal, which is why it really only makes sense to complete the square when this is an even number right here. If it's an odd number, it turns out yucky. And then I would do quad formula or like anything else. X plus 3 plus 3. Yeah, that's kind of unfortunate, but that's okay. So I completed the square. Okay, what's step 3? Add the 9. Then you factor it. Beautiful. Yep. I just rewrote it to make it pretty. Okay, now on this particular one here, I'm going to leave it plus or minus root 2, and I'm going to put the negative 3 in the front so it looks like a quad formula answer at the end. So x equals negative 3 plus or minus root 2. So again, take the negative 3, put it in the front so that it looks like a quad formula answer. So that's the first type. Okay, the second type is called standard to vertex form or standard to graphing form of a parabola. The difference between that and this is I don't have equals 0, I have equals y. So again, standard to vertex form or standard to graphing form, I don't have equals 0, I have equals y. So my goal is to take that and make it look like AHK. Okay, so the steps are very similar. Move the constant first. Okay, now this is going to feel really weird. Just write y minus 9. Don't worry about it. Just leave that. Are you guys okay so far? Okay, now do the box. Are you guys okay? Okay, what goes in the first box? X squared. And how many X tiles are going to go in each of these? 2X. You're doing it. I can tell it's coming back to you. Okay. Plus 4. Plus 4. Okay, after the box, what do we do? Factor. Nope. Add the 5. The goal of this is different. Yeah, so A is 1, H is -2, K is 5. Now you can do the vertex and describe the transformations. So the goal is different. You're not solving for the variable, you're rewriting it to vertex form. Do you use the same thing to do two completely different things? There was a lot of exploration before our time.
And like, how do we set that up where it's like y equals whatever, so we can just subtract everything on both sides of the equation of the equal sign.
And they didn't have calculators or like even paper. They're just writing in the sand with a stick.
I know, what is numbers?
It's just
What's the
geniuses.
square root?
Okay, so now for 132, we're gonna do the spiciest one I could find. This is like the most challenging that this problem would ever get. So it's not actually because I think it's pointless to complete the square root fraction. But I could tell you there might be a fraction one on a team test, but I wouldn't do that to you like regular style. Who? Oh yeah. But that's where you're supposed to learn this is math too. So okay, now the first thing I want to tell you is don't freak out about the f of x. Just y. Don't worry about him. He's fine. Over there in the corner. Just treat him like y. But this one, we have to be really careful. And the reason is because of that 3. So the 3 is what makes this problem spicy. Everything else is the same as the previous one. That 3 throws us into having to be really careful. Okay, so we're going to write steps out. We're going to be careful and go slow. Step 1, move constant. I feel like that step is a constant. Oh. Okay, so because this is notes, I'm going to rewrite it, the problem down again. You don't have to. Okay, if you were in Mr. Guinan's class, you'll divide by 3. I'm not going to do that because it makes the process really long. Now, if you want to divide by 3, you go on ahead. Please divide by 3. It's just going to make this gross. But I am going to factor out the 3. This is because I'm lazy and I don't want to write as much. So what I mean by that is okay, it's the same thing as you're dividing by 3. It's the same thing. It's just doesn't make a huge fraction on this side, which I don't like the looks of. But I promise you it'll come out the same in the end. Okay, step 3, box. We haven't really gotten very creative with our boxes here today. Okay, now this is the moment of truth. So if you've tuned me out at all in the last few minutes, tune me back in right now. Okay, I'm going to add 4 to this trinomial because that's 4. However, if I add 4 to this trinomial, it's not really 4. What is it? 12. Okay, so on this side, you have, okay, so imagine the distributive property, right? So 3x squared plus 12x plus 12. So you have to add 12 over here. It's not really 4, it's 12. All you have to do is just distribute in your mind and go, okay, 3x squared plus 12x plus 12, and then just go plus 12. Step 4, factor. You just have to go slow on that part.
That's a problem.
Yes. Sure. Okay, we have one more to do. That's number 134. I know we went in a weird order. Number 134 is the circle. So the last complete the square is the circle. You guys probably have room on your paper. I did not, so I went to a new page, but I really should have just done it at the bottom of this page. I don't know why I didn't. Last problem. You'll remember this as soon as we start doing it. You did. No, it's easy. It's easier than the vertex form with the leading coefficient. I promise you it's easier. What we just did, the thing with the 3, it's easier than that. This isn't hard at all. I promise it's not bad. It's just got X's and Y's in it, so it looks bad, but I promise it's not.
Oh my god.
Cody's like, I don't believe you. I'm in non-believing state. Okay, so this one has X's and Y's. So the first thing you want to do is just group your X buddies together. And then group your Y buddies together. And move the constant. Oh no, you didn't write -11. -11 cross out. Yeah. It's good though. It's good, right? You see what I did? You good? You sure? Yep. Okay. So now over here, I'm going to do a box for the X's. I know. Haven't seen this one before today. At least the Y's are different.
I'm really happy that it's all the same.
Okay, now I'm going to do a separate box for the Y's. And this is our first time of having a negative. So we have a total of -8 Y tiles. So you want to put -4 Y tiles there and -4 Y tiles there. So Y, -4, yep. And just make sure you put plus. Okay, so you got your two separate boxes. You add 4 to this one, which means you add 4 to that side. And then you add 16 to this one, which means you add 16 to that side. And then factor. Okay, and then the center is -2, +4, because you switch the sign and switch the sign because they're in parentheses. And then the radius is the square root of 9, which is 30. We can do the circle if you want, but you want to draw the circle? Okay.
Yes.
Oh,
I'm gonna do it.
So you said, I'm gonna do.
but that wasn't, I think this one's better than the one before it. Because there's no numbers in front.
It's like, I can do